Hello colleagues, in this discussion we are looking at how we can use superposition theorem to determine the branch currents. So we have solved this same problem using mesh analysis. So we want to see if the answers agree. So first of all, let's look at superposition. So superposition principle, obviously it says that if you have more than two voltage sources, of course, what you're going to do is short circuit one. If you have a current source, you open circuit. For these voltages, we are going to short circuit one and leave one operating in the circuit. Then later on, we short circuit it and replace the other one that we had short circuited. So let's begin with, let's start with the one of 10 and we short circuit the 20. So this is what is going to happen. We are having our circuit like this. So part B, we are looking at superposition. So our circuit, consider the 10 volt source and short circuit the 20 volt source. So this is what is going to happen. You have your source there, you have the impedances, you have a resistance of 5, then you have another impedance here. So you have 3 plus J4, you have 5 ohms, you have 3 minus J4, then we have the 10 degrees volt source. So let's consider the fact that the current coming from here is I. So when it comes here, it will be I5, maybe prime, and the one coming here will be, okay, let's consider it to be I1 and I2 for simplicity. So we have I1 prime and I2 prime. This is just for the sake of the first 10 degrees 10 volt source. Now, the second one we shall consider it to be I double prime, I1 double prime, and I2 double prime. So let's proceed. Now, what we're going to do is to look for the total impedance. So total impedance here is going to be I'm going to multiply, of course these are two parallel impedances, so I will multiply them, then take the sum also. So I'll have product, which is 5 times 3 plus J4, then everything divided by 5 plus 3 plus J4. Then remember they are in series with this, so I will add 3 minus J4. So this is going to give me, if I evaluate that, it is giving me a value equivalent to 5.5 minus 2.75 J, and this is equal to Z total prime is equal to 6.149 at an angle of 26.57 degrees. Now, if I get the total, remember I can use Ohm's law so that I get this voltage divided by this to get my current. So the current I prime is going to be voltage 10 at an angle 0 degrees divided by 6.149 at an angle of negative 26.57. So our current is actually going to be, this is going to be 1.55 plus 0.727 J. If we wanted it in polar form, then this can be, I have 1.455 plus 0.727 I, then I take it polar form. So this is going to be, 1.627 at an angle of 26.55 degrees. But then we can using current division rule to determine the current in, of course, the 5 ohms and the 3 plus J4 ohms. So that is I1. So I1 is going to be, usually what we do for current division rule. So if I want I1, then I will use I2. So I'll have 3 plus J4 divided by 5 plus 3 plus J4. So I1, which is through the 5 ohms, is going to be 3 plus J4 divided by 5 plus 3 plus J4. Then, of course, I multiply it by the total current. The total current was 1.455 plus 0.727 J. Now, if I do that, multiplying by 3 plus have J4, so 4I. Okay, I'm dividing it by 8 plus 4I. So I'm going to get a value I1, which is 0.545, so 6, then plus 0.727 J. If we want to get I2, of course, this is going to be I minus I1. So this is going to be 1.455 plus 0.727 J. We take away 0.546 plus 0.727 J. And this is going to be, so I'm getting 0.909 amps. So meaning these are primes. So for the first source, the 10 volts source, this is what we are getting. Now let's consider the 20 volt source on and short circuit the 10 volts AC source. Of course, this is also AC. So what is this going to be? I will have the other impedance 3 minus J4. Then you have the resistance 5 ohm. Then you have the impedance here, which is 3 plus J4 ohms. And the source. The source that we are having here is the 20 at an angle of 0 degrees volts. So let us consider the current going through here to be, this is going to be double prime. So we consider this to be I 1, okay, double prime, and the I2 double prime. So what is that going to mean? I need to look for total impedance. So total impedance for this source now is going to be, I'm going to multiply the two, because they are in parallel, divided by their sum. I have 5 times 3 minus j4 divided by 5 plus 3 minus j4. Then remember they are in series with the 3 plus j4 ohms. So if I do that, I'm getting 6.14926. So Z total is 6.149 at an angle of 26.57 degrees. So the current, this one total will be voltage divided by impedance. So this is going to be the 20-volt source divided by 6.149 at an angle of 26.57. So we have 20 at an angle of 0 divided by 6.149 at an angle of 26.57. So the total current that I'm getting, so current is going to be negative 0.132. Let me repeat. So add 20 at an angle of 0 divided by 6.149 at an angle of 26.57. So I'm getting different value here. So I'm getting 2.909 1 and minus 1.455 J. What does that mean? The I1, which is going through the 5 ohms resistor, this is going to be, of course, it is in parallel with the 3 minus J4, so it will be 3 minus J4 divided by 3 minus J4, then plus 5. So I multiply by the total current, which is 2.9091 minus 1.55 J. I get my answer that I got above times 3 minus 4 I. I divided the answer by 8 minus 4I. So I'm getting I1 double prime as, so we have 1.092 minus J 1.455. Then obviously the other one would be now this one 2.9091 minus 1.455 J. You take away 1.092 minus 1.455 J. So minus 2.9091 minus 1.455 J. So the value I'm getting is 1.8, 1.88. So I2 is equal to 1.818. So this is going to be, so it is at that level. So we get, so now to get the current through the 10-volt source. So this is going to be, first of all, remember what came from the 10-volt source. We had I1. Okay, so we had not I1, but I, specifically, which was 1.455. So 1.455, remember now what is passing through is I2 double prime. So I'm going to get 1.455 plus 0.727J. Remember, what has been calculated is 1.818. So I have 1.455 plus 0.727J plus 0.727J minus 1.818. So we are getting negative 0.363. So we need to add another one. This is 0.727J. So if I look for the polar form, I'll have 0.8126 at an angle of, this is at an angle, so at an angle of 116.53 degrees. Next is the current via the 20-volt source. So remember, the 20-volt source has produced this value of 2.9091. Okay, so remember there was a current I2 that flew in there. That I2 single prime was 0.909. So I'm going to get 2.909 minus 1.455J, then we take away 0.909. So I have 2.9091 minus 1.455I minus 0.909. So what we have here is actually 2 at an 1.455J, and if I'm to convert it to polar, this is going to give us 2.473 at an angle of negative 36 degrees. Now the current via 5 ohms, remember in the beginning we had the I1 flowing through, and the I1 was 0.546 and plus 0.72J. Then in the next step we had I1 double prime also flowing there, and I1 double prime was equivalent to 1.092 minus that. So we are going to add the two. So this is going to be 1.092 minus 1.455J. Then we are adding 0.546 plus 0.727J. I'll have 1.092 minus 1.455I. We are adding 0.546 plus 0.727I. So we are getting a total of 1.638 at an angle, of course not at an angle, but minus 0.728 J. So I want to convert this to polar form, and this is going to give us 1.792 at an angle of negative 23.96 degrees. So that is it, dear friends. That's how we could calculate the values in each of these branches. Thank you.